So this is 8th grade. Is that working? Yes, looks like it's working. 2-4. So this is all about equations with no solutions, infinite many solutions, or one solution. And I should have got some more scratch paper. But let me just give you some simple examples here. So if there's no solution, how about something like x plus 2 equals x? Is there any way we could solve that? No, because no matter what x is, these are not going to be equal. And so there's not going to be a solution for those kinds of equations. How about if I wrote something like x plus 13, let's see, equals x plus 10 and plus 3, okay? You can look at that right away and see that they're really both going to be x plus 13 because you just combined your like terms, although technically they didn't have a variable in them, but you understand what I'm saying here. So in this case, it would have infinite many solutions. It doesn't matter what x is. It could be a negative number, it could be a fraction, it could be a decimal, it could be into the millions or billions. They're going to be equal. So infinite many solutions. And then, of course, what we've been doing in the last several lessons is solving problems where there's just one solution. You get x isolated by itself on one side of the equation, and so that would have one solution. So let's look at the examples really quick here. It says solve an equation with infinite many solutions. And so here we have 2x plus 3 plus 2x plus 3 plus x plus x. And on the other side we have 2x plus 2 plus 2x plus 2 plus 2x plus 2. They're set up a little bit differently, but when you combine like terms, what do you end up with? On the left side here, you end up with 6x plus 6. On the right side, you end up with 6x plus 6. Right there, you know that it doesn't matter what x is, they're going to be the same, all right? And so because 6 is always 6, all the values of x will make the equation true. This equation has infinite many solutions. No matter what you plug in for x, it will work. Okay. Let's look at the try it at the bottom of the page here. It's asking how many solutions does this equation have? So let's take a look here. What do we have here? We have 3x plus 15 equals 2x plus 10 plus x plus 5. Okay? Wow, it looks like a lot. Well, let's combine some like terms for starters. So I'm not going to worry about this side, 3x plus 15. There's not a whole lot I can do with that, but I'm going to look over on the right side here. I see a 2x, and there's an x. What's always to be assumed in front of every variable? I heard somebody say it all right. Mr. Dickerson isn't here. Ms. Kurz, what's always to be assumed in front of every variable?
1.
A 1. All right. So if I combined like terms, I have a 2x and then a 1x. That's going to equal 3x. And then 10 and 15 is what?
10 or 15.
Yeah, not 10. Okay. So now we have 3x plus 15 equals 3x plus 15. I mean, I could keep going, but you guys already recognize that it doesn't matter what x is. At least I hope all of you recognize. It doesn't matter what x is. It's going to have infinite many solutions. So I still want to get x by itself here, so I could subtract 15. Subtract 15. Now I have 3x equals 3x. All right, that's what's left. Now, again, I could go a step further. I want to get x by itself. Well, what do? What's happening to the x? It's being multiplied, so I want to divide. I'm going to divide each side by 3. Whatever you do on one side of the equation, you do on the other. So 3 divided by 3 is 1. I could write 1x equals 1x, or simply x equals x. So it has infinite many solutions. Okay? Let's see, solve with, looking at, oh no, scratch out the convince me at the bottom of the page. I'm not worried about that.
But how many solutions do we have?
Infinite many, infinite many. All right, example 2, it says solve an equation with one solution. I'm not even going to bother with that one because we've been doing these for several days now. You guys know how to solve those. They walk you through that one. You guys should be able to solve equations with one solution. Example 3 here. Look what they did here. So here's our equation. We have 3 in parentheses 2x plus 5 equals 2 times 3x plus 3. Well, so they use the distributive property. 3 times 2x is 6x, and 3 times 5 is 15. Okay, that makes sense. 2 times 3x is 6x. 2 times 3 is 6. So that's what we have. So we have 6x plus 15, 6x plus 6. Already you can tell this isn't going to work. No matter what you put in for x, they're not going to be equal. Okay? And so they isolated it. They got rid of the x's. Well, does 15 ever equal 6? No. So this has no solution because 15 is not equal to 6. All right. So I circled the try it at the bottom of page 109. It says, how many solutions does this have? So I want you guys to try to do that one. Turn to page. Example 4. You're going to get problems like this. It says determine the number of solutions by inspection. In other words, they're just saying look at it. How can you determine the number of solutions in each equation it has without solving it, without going all the way? Sometimes you guys only have to go 1 or 2 steps. And oh, I can see what that is. So here's the first example. We have an x plus 3 plus 7 equals 2x minus 10 minus x. So let's combine what we can. So we have an x, and 3 and 7 is 10. So we have an x plus 10. Over here on the right side, we have 2x minus 10 minus x. Well, I can combine these like terms. So that's going to be an x minus 10. Is there anything that we could plug in for x that would make these two equations equal? No, we can't. So you can tell right away, without going all the way, that it's not going to work. There's no solutions for this equation. So that's what they're talking about. You'll have some problems like this. Say, don't solve it. Just determine after a step or two if there's one solution, no solution, or infinite many solutions. How about this one? Distributive property. It says 3x, and then 3 times 4 is 12, so 3x plus 12. And then over here we have 3x plus 12. Whoa, what do we got here? Infinite many solutions. Don't need to go any further.
Whoa.
Amazing, huh, Mr. Holmes?
Yeah.
Yeah, okay. All right, Mr. Holmes, look at C.
Okay.
All right, so we have 5x plus 8 equals 2x minus 1. Well, what do they do here? Looks like they subtracted the 8 on each side. And so then we're left with a 5x on one side and a 2x minus 9 on the other. Then they subtracted the 2x and got 3x equals a negative 9. Well, if we took it a little bit further, and we don't need to, you can see that there's going to be one solution for x. There's going to be an answer, but only one answer. And how would we do that? Let me pull a stick here. Mr. Hanley, if I wanted to solve this equation, what's the next step I would do? Right here, yep. What's the next thing I would do? So this is what we have. 3x equals a negative 9. I wanted to figure out what x is. What's the next thing I would do?
Would you divide both
Divide each side by 3. That's all right. X equals negative 9 divided by 3 is a negative 3. So it has one solution. Okay? And so they say this equation right here has one solution. All right, so circle the try it at the bottom of page 110. I want you to do A, B, and C.
Look at how much the lesson is. It's like 27 questions, bro.
Is that too many for you?
Yeah.
It is?
Yes.
Oh, okay. I'll add some more here.
Oh.
Okay.
Okay.
Yeah.
That's
Yeah.
good practice.
Yeah. So here's one. So we'll call this A, B, C. We'll call this D, Mr. Holmes. You get to do this one.
Oh, okay.
Okay. So 3x plus a negative 7x. Okay. Minus 15 plus x equals. I'm going to do x plus x. Okay. Times x, okay, minus 3x minus 2x plus 10, okay. Solve for x. Got that written down, Mr. Holmes? Because that is now part of your grade here, because you had a problem with how many problems you got here. So, just you.
I'm doing it. 67.
Okay. So, back to what we were doing here before students were complaining about their work. So, number one here, will a one variable equation always have one solution? They're talking about one variable, x or w or z or whatever it is. No, it could have many solutions or no solutions. And so I just drew the arrows up here because they explain that. All right. Number two. Let's look at that for a moment here. Kaylee writes that the equation 6x plus 12 equals 2, and then in parentheses 3x plus 6. Can you find the number of solutions this equation has without solving for x? Well, 6x plus 12, I'm going to write that. 6x plus 12 equals 2 times 3x is what? 6x. What's 2 times 6? 12. What do we have here? 6x plus 12, 6x plus 12. I haven't gone any further. I'm not solving it, but can you find the number of solutions this equation has without solving it? Yes. Explain. Well, we just did it. We see. All right.
That's a really good example.
Glad you're happy with it. Number 3. Want you to do that one. So you've had problems similar to this. It says the height of an experimental plant after x days can be represented by the formula 3 times 4x plus 2. The height of a second plant can be represented by the formula 6 in parentheses 2x plus 2. Is it possible the two plants will ever have the same height? Let's set it up. 3x, or 3, and then 4x plus 2 equals 6, 2x plus 2. There you go.
Mr. Glazer?
Yes.
Never mind.
Good idea. Hang on. I don't want to run out of time here. 4, 5, and 6, circle those.
After you're done doing that, can you go back to the try it so I can copy it?
7. I'm just worried about the last box. 8, just the last box. 9, it says, what does it mean if an equation is equivalent to 0 equals 0? So infinite many, because 0 is always equal to 0. Again, infinite many, because 0 was always equal to 0. Circle 10 and 11. And then at the top of page 113, circle 12, 13, 14, and 15. So for 12, I answered that for you. How is solving an equation with no solution similar to solving an equation that has an infinite number of solutions? And here's the answer. It says when you solve for the variable can be eliminated from both sides of the equation. Again, when you solve for the variable can be eliminated from both sides of the equation. So that's what's similar between solving with no solution or infinite many.
Eliminated?
Infinite number of solutions and no solution. With both of those types of problems, the variable can be eliminated from both sides of the equation. All right, again, circle 13, 14, and 15. So 14 here says your friend solved this equation and got this. Scratch out what error did your friend make, but I want to know what the correct solution is. So underline that. That's what I want you to do. Scratch out what error did your friend make. I want you to solve it. 15A, do that. Scratch out B, not worried about it. 16, circle that. 17 down at the bottom. I just want you to solve it. Solve 6x plus 14x plus 5 equals 5, and then in parentheses 4x plus 1. Solve it. 18, circle that. 19, scratch it out, not worried about it. 20, 21, 22, 23, 24, and 25. Circle all those. So yeah, lots of math for you guys. But the good news is, if you guys have a good understanding of the last 2 or 3 lessons, this should be pretty easy for you. You should be able to recognize quickly if it has one solution, infinite many, or no solutions. All right.
Can you go back?